I'm just gonna do a quick little intro and then we're gonna get straight into our midterm review. I don't want to waste too much time. But again, just to remind everybody, if you've never been here, in case you forgot, I'm pretty sure you don't even have the options currently to turn off your microphones or unmute your, or turn on your cameras. So the reason that is because if we're gonna record this, I have to make it so it's private. So no cameras, no microphones. So I'm gonna have to ask everybody to use the chat to ask questions or answer whatever questions I ask. So please use the chat for any type of questions that you have, or answers that if I ask you to put answers in the chat or something, please use the chat for that, to do that. And what else? And as far as the recording goes, so how it's going to work is this session is going to be recorded. Usually I would have to wait for our editor to finish with the YouTube video, but seeing as how your midterms on Monday, you're just going to get the recording on as soon as it's recorded, honestly. So I'm going to wait for Zoom to send me the email that it's ready to be downloaded, and then I'm going to upload it to my Google Drive, and then you should all have, I'll send you all the link to the video with the email that you put when you filled out the form just now. So be on the lookout at those emails today. Hopefully as soon as Zoom sends me the email, I'll give it out to you, everybody here. So hopefully I'll make it as quick as possible. You can spend today, Saturday, Sunday, whatever, studying. But yeah, are there any questions before we get into it? I just want to remind everybody that we have an hour and a half SI session on Monday for review. So anything that we don't get done today, we'll hopefully get done then, which is good because we can get into more detail right now. Probably gonna do about 2 problems, maybe more, I'm not sure. We'll see what time permits. But again, today's session's an hour, but I highly recommend you come to Monday's midterm review session, which is an hour and a half. It's probably gonna be a little bit more thorough in that session than in this one. So are there covered, I think, questions 5, 8. I'm trying to remember the last one. Sorry, one second. Let me pull it up to my email somewhere. Yeah, so you guys covered 5, 6, 8, and 10 in class. We did 1, 2, 3, or 1, 2, and 4 in our last SI session, so I'm not going to cover those for now. If we have time, maybe we can come back to it for those who weren't there. But and then also number 3 is currently not possible to do given the information on the page. So I'm just gonna cross that one out. So today the plan is to at least get through 7 and 9. I'm pretty sure we can possibly make it to 11 as well. So those are the questions we're going to be doing today. So let's just hop into it. So let's look at question 7. So question 7 says a 2.0 kilogram piece of wood slides across a curved surface. The sides of the wood are perfectly smooth, but the rough horizontal bottom is 30 meters long and has a kinetic coefficient friction with 0.2 with the wood. So the sides of the surface are perfectly smooth. Keep that in mind, but there is friction on the rough horizontal bottom, as you can see in the diagram. So it says the piece of wood starts from rest 4 meters above the rough of the bottom. So I guess this distance here is 4 meters. It says when will the wood eventually come to rest and be, I'm guessing that's work done by friction. I'm gonna assume it's cut off, but let's just assume it's work done by friction because I don't know what else could be there. So let's get into this. Let me copy the question over real quick. So let's see what we know and what we don't know. I think that's the best move for these type of problems, right? We know that the wood starts 4 meters above the rough bottom. So that's 4 meters right here. I'm gonna say that this is what we know, right? Knowns. I'm just gonna call that height, right? So we got height is equal to 4.0 meters. We got the mass of the wood, so I'm gonna say the mass is equal to 2.0 kilograms. Okay. The horizontal bottom is 30 meters long, so I'm gonna say, I'm just gonna call that L, right, for length. That's 30 meters. Make sure you put the right significant figures when you write this down. And then the coefficient of kinetic friction between the wood and the rough bottom, so mu sub k mu sub k is equal to 0.20. So that seems to be everything that I'm given by the problem, right? So that's really it, right? So now I can actually get to solving the question. So I'm asked to find out how far what does the wood travel in mind. Any other questions before we move on out of here? Okay, for sure. So now what our next step is, right? We need to determine, I mean, we said we don't know whether or not this potential gravitational energy is zero, right? It could be zero, it could be not zero. It depends on if it reaches the rounded surface of the other side of this path. But we need to see if there's a way to figure out whether or not it's actually gonna travel that distance. So what we can do is we can take this formula. Do you want? Let me move some stuff. I do not have enough room currently. Give me 1 second. Okay. We can use the I'm just gonna change pages. That's what I need to do. All right, so we're left with this formula based off what we've done, right? Kind of rewinding a bit. Well, we need to determine whether or not there's something on our right side. We need to determine whether or not this holds a value. And the way we determine that is we need to figure out whether or not the box reaches the other curved side. The other curved side has height, right? The floor does not have height, but we need to figure out whether or not it reaches here. And we can figure that out using our work due to friction, right? Because we've kind of discovered the thing that's slowing us down is our work due to friction. So based off that information, okay, we can determine that the if the if the number that we solve for this entire distance, right? Because let's just imagine, right? The block moves this entire distance and there's friction acting on it the whole time because this is rough. If the work due to friction here, right, is greater than our initial potential gravitational energy, well, then we have to have some number here, right? We have to. So that means that the block ended up reaching the curved side and it did have a height. Because if potential gravitational energy is only if it's equal to mgh, well, these can't be zero, these two, so it has to be this one that is non-zero if it has a positive value on the right. Is that clear? How we use that reasoning to figure out whether or not it has a height? I can re-explain because I feel like I was a little all over the place, right? So we have friction acting on the wood block throughout this entire distance, okay? Meaning that there was some work being done on it, throughout this distance, right? Friction did work on it. So we can say, okay, well, if the work due to friction here is greater than the initial potential gravitational energy, well, then this can't be zero. So it has to have reached some height. Is that clear? Okay, cool. So let's see the math, right? I think if we look at the math, it'll be a little bit easier to understand what's going on, right? So what I'm going to do is I know that this horizontal bottom is 30 meters long. So I'm going to plug that into my friction equation. So I said friction, or the work due to friction. I'm sorry, the work due to friction. So the work due to friction is, yeah, right. That's what we're trying to determine. We're trying to determine whether or not friction causes it to stop before it reaches the curved bank or after. So meaning it has a height. And we'll see if we can do that. Yeah. Okay. So the work due to friction, we said that the force due to friction, right, is 3.92 newtons, right? That's what we said. That's the friction force, right? 3.92. Well, I know the rough bottom is 30 meters long. Okay, so 30 meters. And we determined that the angle between friction and distance is 180 degrees. So that stands the same, right? So we got cosine of 180. Okay, if I was to plug this in, right, 3.92 times 30 times cosine of 180, should get roughly negative 117.6. And that's in joules, right? Because it's Newton meters. So Newton meters is 1 joule. I get negative 117.6, right? And that checks out. Friction is causing it to slow down. So its force is pointing towards the left. Well, that's usually what we determine as the negative axis is left. So negative 117.6 joules, right? It's slowing it down, which makes sense because friction slows objects down. So that's the value we get from plugging in this 30 meters, okay? So if this number is, if the magnitude of this number, right? Let's look at the magnitude of this number. If the magnitude of this, hold on, I put it over here, right? So the magnitude of this number is negative 117.6 joules, right? So friction did 117.6 joules on this object of energy. Well, let's figure out what this value was, right? Let's figure out what our initial potential gravitational energy was. And we can compare the two, and then we'll make our determination from there. Okay, so U sub I is equal to 2.0 kilograms times 9.8. I'm literally just copying this right over from here. 9.8 meters per second squared times 4.0 meters. Let's see how much energy was being pent up in that potential gravitational energy. 2.0 times 9.8 times 4. That's equal to 78.4 joules. Okay, so let's take a look for a second, right? Let's redraw this image. So we have our little curved bank, and this is the rough area. If all of this energy got converted right back into potential gravitational energy, right? Let's say it started here and it reached here. We would have the same amount of energy here, right? Which means no work could have been done on this object throughout this path. But if we see, it did 117.6 joules of energy on it going this way. So the amount of work done on it in the negative direction was greater than the amount of work done on it in the positive direction. So is it possible for it to have reached a height if more work was done on it going this direction than this direction? Seen some no's. What else do we think? What does everyone else in the chat think? No. Okay, but so yeah, we kind of see that we have that intuition, right? If more work is done on it going towards the left, well then of course it couldn't have traveled all the way past this area, right? It doesn't work that way. So no, right? So we determined that there was no height at the final. It did not reach the other side of the curved bank. In other words, the potential gravitational energy at the final position was 0. Okay, and that might seem a little confusing, right? It's like, okay, well, I have a positive number here or a negative number here. But in reality, we don't have, I mean, not a negative number, I'm sorry. We have some number here, but then we have a 0 here. Well, that's not really true, right? This is in the case that it went across the entire rough surface. But that's not what it did in reality, right? In reality, it stopped somewhere. And now we need to figure out where it stopped. So rather than plug 30 into our work dot distance here, we're going to plug in some number that will make this equal to 0. So we'll see. Let me copy this, right? Actually, let me rewrite it. So we basically need this to be 0, these two. Because this, if the right side is 0, well, then these two have to add up to 0. And well, there's some number here. So basically, we need to find some distance that will make the work due to friction equal the initial potential gravitational energy. And we can do that, right? We determine that this is 78.4 joules. Okay. And we're going to do plus the work due to the force due to friction, which is 3.92 newtons, times some distance that it actually traveled, or the answer to this question, times cosine of 180. Okay, and that's going to equal to 0. In other words, we need to make it so that this is equal the force due to gravity. I'm sorry, the work due to friction. Yeah, I'm all over the place, right? The work due to friction, cosine of 180, is equal to negative 78.4. Do we all follow along to how I got to this reasoning and why I did this method? Are there any questions? Yeah, and so at this point, we're just solving for D, right? Well, we know it's on the flat edge, so some distance D. And that's what's going to tell us how far it stopped. How far did the block travel such that the work done on it by friction is equal to negative 78.4 joules? Is that a little bit more clear? Because we determined, right? We determined that it's impossible for it to reach some height on the other side. So that means all of this potential gravitational energy had to become kind of counteracted, right, by the friction. So they had to be, and this side's equal to 0. Well, so this side has to equal to 0. Well, we just need to find some D such that this side is equal to negative 78. Negative 78.4. Is that clear? You guys can use the reactions in the chat, or on your little names. Yeah, yeah. All right, for sure. Okay, well, I've done a lot of talking, so I'm gonna let you do the math for this. Please solve for the answer for D and then drop it in the chat. Oh, there we go. That was fast. 20. 20, 20. Okay. So keep those answers coming. Even if they're already in the chat, please continue to answer so I know you're engaged with us here. Okay, I was about to say, I was like, negative 20. That's confusing. Yeah, it's 20, right? And let's see why it's 20. Well, I got cosine of 180 is equal to negative 1. So then I got negative 3.92 newtons times D, which is equal to negative 78.4. 78.4 joules. So then I do D. I'm going to divide by negative sign. Negative signs cancel out. We got 78.4 joules over 3.92 newtons. Well, let's think about it. Joules is Newton meters. And then divide by newtons, I'm left with meters. So my units are correct. And if you plug this in, you should get roughly about 20.0. Well, let's look at the original question, right? How many sig figs did we have? We had 1, 2. We had 1, 2, 3. Well, 1, 2. We know that our answer is probably going to have, actually, then we had 1 sig fig here, right? So our answer is going to have 1 sig fig. So 20 meters. Okay. Do we all feel comfortable with getting to this answer? What's good is you get the video at least after this, so you'll be able to hear me explain it over and over. But do we have any questions right now? Okay, and it looks like we got no questions. So let's look at part B, right? I think part B should be really easy now. So it's asking us, what is the work done by friction? Okay, well, we already solved for work done by friction up here. Okay, how do we know which energies we can cross out? Yeah, so let's go back a step and take a look at that. So initially, we're told by the problem that we started at rest. So we said the wood starts from rest 4.0 meters above the rough bottom. Instantly, we know that initial velocity is equal to 0. Kinetic energy is equal to 0, right? If Ke is equal to 1/2 mv squared, well, then it never had a chance to have potential gravitational energy. Does that make sense? I know I talked a lot, but okay. Hopefully that's clear. Again, we are going to get the video after this, so hopefully it's a little bit more clear then too. All right, so let's do part B now. Part B seems pretty easy, I think, after we... Yeah, right, negative 78.4. We figured that though, right? We said earlier, the work done by friction has to be exactly like counteractive to the potential gravitational energy. So it makes sense that we got negative 78.4, right? It all comes together in the end. So that means this is equal to negative 78.4 joules. Okay, and that was question 7. Are there any questions before we move on? Those questions are pretty tough, right? So hopefully we all have a good understanding of it now. Any questions before we move on? All right. Maybe someone's typing it up. I know since we can't talk. If you're still typing, great question, please go ahead. But I'm just gonna copy over question 11 in the meantime, or question 9, I mean. I think question 9. Yeah, question 9. Okay. So question 9. No, this one's a little weird, right? I've seen this one before. So it says 1,000-kilogram cart moves along the x-axis and reaches to the top of the first hill at 1.2 meters per second. And it tells us which one's the first hill, right? This one right here. So it reaches the top of the first hill at 1.2 meters per second. Can the cart travel to point A? Point A being the tip of the second hill. Okay, and it also asks us how high can the cart travel to the last hill? So this one right here. So how high can it travel up there? Okay, well, let me copy this over and we can see what kind of physics we can do on this problem to figure it out. Okay, new page. So let's see. All right, well, I'm given a velocity and I'm not really given much else, right? I'm given a height. Yeah, I am given a height. And it's asking me, well, if it can travel up the first hill, can the cart travel up the second hill? And it gives me some numbers, and from there I need to do my analysis. So much like the last problem, right? It's not too difficult to tell which topic, which method do I need to do to solve for this problem. I'm given a height, I'm given a mass, I'm given a velocity. There's no time, there's no acceleration, there's nothing like that, right? So I mean, to me, it looks like I'm gonna have to use conservation of energy, just because I mean, based off my analysis, there's not much else I can do, and conservation of energy lends itself well to these type of problems. So that's what I'm going to use to solve for it. Okay, well, let's see if we can make our conservation of energy like table here, right? We have initial, not table. What am I saying? Equation. Why did I say table? We have initial energy equal to final energy, right? And like always, we got our KEI plus UI plus, which is equal to KEF, right? No friction, nothing else involved in this problem. Just just kinetic energy, gravitational potential energy, right? Nothing else. And final. So, and let's see if we are going to be able to cross any of these out. Well, it says that it travels up to the top of the first hill. So if we are currently at the top of the first hill, right? What does that tell me about my potential gravitational energy? My initial potential gravitational energy. Okay, so we're saying it's 0. We have one. Okay, so we're seeing a little bit of difference. Can everyone else in the chat put something so we can see if we can come to an agreement here? Or your thoughts at least? Velocity 0 at the top. Okay. What do we think as far as the potential? Do we have an initial potential gravitational energy? It doesn't really tell us, right? I mean, it tells us the velocity at the top of the first hill is 1.2 meters per second, but it doesn't really say much else. Okay, no. Anybody else? Okay, so it looks like we are not 100% on this problem. No worries, we'll see what we can do. So I can't make that determination now. If I figure that h is equal to 0, well, then I don't. But, we'll see from there. But I have a question for you all. Do I have a final kinetic energy traveling up the last hill? At the max height that I travel up the last hill, do I have a final kinetic energy? No. No, I don't, right? We know once we reach a maximum height, there's no velocity at that point. It starts to go back downward. So I do not have a final kinetic energy because I know that my velocity at the final position is going to be 0. Because it's saying how high can the cart travel up the last hill? What is the maximum y value that it can travel up the last hill? Well, if we remember from kinematics, right, projectile motion, when something's at its maximum y, its y velocity is 0 because that's the point at which it starts to go negative. Okay, so I mean, at this point, it's just math, right? I just need to solve for the final height, and I can see what that value will be. So I have 1/2 mvi squared plus mg h sub I, which is equal to mgh sub f. I'm going to say just f. You can call it h sub 1, h sub 2. It doesn't really matter. And I just have to rearrange this formula to solve for the final height. Okay. Well, what am I going to do? I'm going to cancel out the m's. All right. And then I'm just going to rearrange some stuff. So I'm left with 1/2 vi squared plus gh sub I, which is equal to h sub f. Well, at this point, I just need to divide each side by g. Okay. And I'm left with h sub f on the right side. So that means h, so the final height it reaches is equal to 1/2 1.2 meters per second, right? That was my initial velocity at the top of this hill. 1.2 meters per second squared plus gravity, meters per second squared, times the height that it started at initially. Well, I started off at an initial height of 16 meters, so 16 meters. Okay, and this is all divided by 9.8 meters per second squared. Okay, and the problem does give you the mass of the cart, but the mass is irrelevant. I just canceled it out. It doesn't help me figure anything out. Okay, so if I plug this into my calculator, I got 1/2 times 1.2 meters per second squared plus 9.8 times 16 meters, all divided by 9.8 meters per second squared. Let me do a bit of unit analysis here. I'm going to be left with, so these meters per second squared are going to cancel out with this one. So I'm just left with meters. Well, height is in meters, so my units make sense. So it looks like I'm on the right track. And if I was to calculate, and then I'm going to challenge you all in the last few minutes to plug this in and calculate it on your own and see what value you get. And then drop your answers in the chat. I mean, not much of a challenge, right? Just plug it on your calculator, but 16. Yeah, right. I mean, you get roughly 16.1. But if we look at our significant figures from the problem, it looks like we should have about 2 because of this velocity here. I mean, we don't really care about. We never use the 1,000 kilograms, so it's kind of irrelevant. This should be about 16 meters. And does that make sense? Well, I mean, it traveled once when all the energy got converted here, it reached 16 meters, and then we got 0 is equal to 0. So that was like the perfect height, right? That it could reach. This was the maximum height it reached here. So I guess it makes sense that up the last hill, it would only reach up 16 meters. So it only reaches up 16 meters of the last hill. Yes, the number of sig figs is 2, right? We at no point did we multiply anything by the mass. So the mass didn't matter. But this had 2 significant figures in the velocity. So we have 2 significant figures when solving for this. Do we have any questions about this one? This one I think was a little bit easier than the first question that we did. Are there any questions at all? All right, so heads up, Monday, please try your best to show up to that session. It's gonna be the last review that, other than self-studying that you have before the midterm. It's gonna be an hour and a half, so 1 to 2:30 p.m. on Monday. Please try your best to show up. As soon as Zoom sends me the link, I'm gonna drop this video in my Google Drive. As soon as that is uploaded properly, I'm gonna email you all the link. I appreciate you all coming today. You're gonna get this video as soon as I get it. So, no, we don't have time for question 3. We only have 5 minutes left. So we can cover question 3 on Monday's SI session. So please try your best. The rest of the problems we're going to cover on Monday's SI session, as well as I needed to check something on question. Oh yeah. So question 3 is not even being given, right? Because you haven't had enough information. So question 3 is not really important. But that's pretty much it. For those of us from our Wednesday session, we couldn't finish question 4. I mean, I just did want to make sure I didn't do anything wrong, but I did figure it out. So I'll explain that on Monday so everyone can see it. But if there's no questions, appreciate you all coming today. You can head out. Good luck on your studying this weekend. I hope you all do well and you all have a good time studying. I would highly encourage you all to study with someone. I mean, I know I'm sure you have a class Discord. Every class has a Discord. So reach out to people in there, study together. It's always better than studying alone. Again, try your best to come to Monday session. Look out for this email with this recording. And then, yeah, good luck with your studying. Otherwise, you can head out, and I appreciate y'all coming today. Yeah, thank you for coming. No worries. Have a good weekend, everyone. I'll stay back a few minutes if there's any questions. I know you guys can't mute yourselves, but chat if you need. We got any questions? Anybody here? Guess not. All right. Sounds good. I'm going to end the meeting. Good talking to you all.